All right, well, hello, my 8th grade friends. Today our focus is on solving linear equations using the substitution method. Now, as you're going to see over the next couple of weeks or so, there is a variety of ways, let me use proper English, to solve linear equations. And as you get into algebra next year, some of you are already taking algebra, your algebra teacher will expect you to be able to show evidence that you understand all the ways of solving linear equations. Up to this point, what we've done, we did it in 8th grade earlier in the year, we've done it the last couple lessons, is simply taking linear equations, putting them in that slope-intercept form, that y equals mx plus b, where m is the slope and b is the y-intercept, and then taking them and solving for x, and then going and plugging x back into the equation to solve for y. And that is what we have done. We've made the equations equal and so forth. Well, there are actually multiple ways of solving linear equations. And over the next couple days, today and tomorrow, we're going to be looking at the substitution method. And when you do the work on the assignment, you are going to need to show evidence of showing the substitution method. Now, essentially, the substitution method requires you to either isolate x or isolate y. It requires you to do one of those two things. Now, example number 1 is fairly easy because x is isolated. It tells you what x equals. X equals 17 minus 4y. It also tells you what y equals x minus 2. So to solve this equation, what I'm going to do is I'm going to use this second equation, y equals x minus 2. And for x, I'm going to plug in 17 minus 4y. So I'm going to be left with y equals 17 minus 4y, because that's what x equals, minus 2. So I want to make that very clear. I just rewrote this equation, 17 minus x minus 2, and I replaced x with 17 minus 4y. How do I know that x is the same as 17 minus 4y? Well, my first equation tells me that. It tells me that x equals 17 minus 4y. So from here, I'm going to isolate. I'm going to combine like terms. All right, I'm going to say, okay, well, I'm going to add 4y to both sides. That's going to give me 0. And so I'm going to come over here and add 4y. That's going to give me 5y. And then I'm going to combine the 17 minus 2, and that's going to leave me with 5y equals 15, because 17 minus 2 is 15. Well, if 5y equals 15, I'm going to do 15 divided by 5, and that's going to tell me that y equals 3. So now all I do is take this, y equals 3, and go back and plug it into one of my equations. Well, if y equals 3, all right, I'm just going to say, well, if y is 3 here, then that tells me that x minus 2 has to equal 3. Once again, you might be wondering, well, how did you come to that conclusion? Well, I've already solved that y equals 3. So all I'm doing is putting 3 in here for y, meaning that x minus 2 has to equal 3. Well, if x minus 2 equals 3, when I add 2 to both sides, that leaves me with x equals 5. And my solution to those linear equations is 5, 3. Because remember what we're doing when we solve a system of linear equations. We are simply finding the intersecting point. And so your work that you show needs to show that you are plugging in and isolating one of the variables. And in this case, we isolated y. All right? So we go to this one. All right, let me draw a little separation line here. Y equals 2x minus 1, 2x plus y equals 3. Well, when I look at these two equations, the only thing that's by itself is y. So I'm going to come to this second equation. And since I know what y is 2x minus 1, I'm going to come down here and plug in 2x minus 1. That's going to leave me with 2x plus 2x minus 1 equals 3. I want to do that again. It says 2x plus y equals 3. Well, that's my first 2x. And for plus y, it tells me that y equals 2x minus 1. So I am left with 2x plus 2x minus 1, because that's what the y is, equals 3. Well, I can simplify things here. I'm going to make that 4x, and I'm going to add 1 to both sides and make that 0. I'm going to add 1 over here and make it 4. The 2x and 2x made 4x. So that leaves me with 4x equals 4. Well, if 4x equals 4, x must equal 1. That's pretty basic, because 4 times 1 is 4. But then I have to go back in and plug it in for the equation. All right, so now I need to solve for y. Now, since y is isolated here, this is the top equation is probably the easiest one to go plug x in for. So if x is 1 and it's 2x, that becomes 2 times 1. Well, 2 times 1 is 2, and 2 minus 1 is 1. So that tells me that y must also be 1. Let's do that again. If x is 1, like we figured out, 4x equals 4, x equals 1. If x is 1, 2 times 1 is 2. 2 minus 1 is 1, which means y must equal 1, which means my intersection point for that system of linear equations is 1, 1. All right? Just a different way of solving linear equations, not putting everything in slope-intercept form, isolating one of the variables. We're going to look at a couple more, but I want to emphasize, grade 8, what we're looking for is for you to make sure that you are plugging the values in, isolating either x or y in the substitution method. Doesn't matter which one you want to isolate. All right, so, well, here we go, number 3. We're going to look at 4. So our first one here, third one, x equals 16 minus 4y. 3x plus 4y equals 8. All right, so let's think about that. Well, the only thing that's by itself is x. So that tells me that down here I'm going to have to plug in 16 minus 4y for x. All right, because we know that x equals 16 minus 4y. So here in my second equation, I'm going to take 3, and since it's 3 times x, I know that it's going to be 3 times 16 minus 4y, because x equals 16 minus 4y. That's what it tells me in the first equation. And then I'm going to add 4y to that, and that whole thing is going to equal 8. So I'm just plugging x in into my second equation. X equals 16 minus 4y. 3 times x, or 16 minus 4y, plus the 4y equals 8. Well, we know a number right next to parentheses means multiplication. So 3 times 16 is 48. 3 times a negative 4y is a negative 12y. And then it's plus 4y equals 8. Well, let's start combining some like terms here. All right, let's subtract 48 from this side. That gives me 0. 8 minus 48 leaves me with a negative 40. Well, then I have negative 12y plus 4y. Negative 12 plus 4 is negative 8, so I think I'm left with negative 8y equals negative 40. Once again, 8th grade, for the most part, you're going to be amazed at how well the numbers seem to work out with the problems that you're given on the assignment. Well, if negative 8y equals negative 40, it becomes negative 40 divided by negative 8. They're both negative, so I know it's going to be positive, so I can just think 40 divided by 8. And that tells me that y equals 5. Well, so now I have to go back and plug in y equals 5 into one of these equations. Well, the fact that x is already isolated here, I think this is going to be the better equation to work with to plug in y equals 5. Because I can come up here and say, well, if y equals 5, 4 times 5 is 20. So x equals 16 minus 20. And I got 20 because y equals 5, and it's 4 times 5 is 20. So x equals 16 minus 20. Well, 16 minus 20, if you plug that into your calculator, 8th grade, most of you shouldn't have to do that, but 16 minus 20, you're going to find that x equals negative 4. which means that the solution to these two lines, if they're graphed, the intersecting point is going to be -4 on the x-axis, 5 on the y-axis. All right? Last one, 8th grade, here we go. 2x minus y equals 23, x minus 9 equals -1. Well, here's one, and this one's different than all the other ones because in this one, neither x or y is by itself. So it's not just an easy look to see what y equals or what x equals. Neither of these equations have x or y by itself. Okay? So here's an interesting situation. We get x minus 9 equals -1, 2x minus y equals 23. Well, if I look at this lower one, x minus 9 equals -1, if I take the time to look at that, I should realize that if I add 9 to both sides, that's not 0, is it? -1 plus 9 is going to be 8. If I add 9 to both sides, -9 plus 9 is 0, -1 plus 9 is 8. That just leaves me with x equals 8. That wasn't too difficult to figure out, but I had to do that. I now know that x equals 8. Okay? So now I have to take that and plug it into this formula, which has my y value. I have no choice but to plug this into this one, because this 2x minus y equals 23 is the only one of my equations that has y. So it's going to leave me with 2 times 8, because x equals 8, 2 times 8, minus y equals, it tells me, 23. Well, that's not hard. 2 times 8 is 16. 16 minus y equals 23. All right, so it tells me, well, I'm going to subtract 16 from both sides. That's going to give me 0. I'm going to subtract 16 from this side. 23 minus 16 is 7. So that tells me that -y equals 7, which tells me I don't want a -y. I'm going to multiply everything by a -1 to change the signs. So that's just going to leave me with a positive y, and it's going to leave me with a -7. So y equals -7. My intersection point is going to be 8, -7. And that's my intersection point. All right, we'll talk to you later, 8th grade. Bye.